Okay, hi everyone. So today's will be the second lesson for our topic 2, which is logarithmic and exponential functions. So for today's learning outcome will be how to use logarithms to solve the equation and inequality in which the unknown appears in indices. Okay, what is this statement actually means? So in short, we are going to learn three things today. So for the first one is how to solve a logarithm equation. The second one is how do we use logarithm equation to help us to solve exponential equation. So when we talk about the logarithm equation, meaning that the equation is given like in logarithm form, so what we need to do is simplify it, then after that solve it. So for the second one is how do we use the concept in logarithm to help us to solve an exponential equation, meaning like when you look at the equation itself, there's actually no log, but they are in exponential form. And the third thing is how do we solve exponential inequality. Okay, so these are the three focus that we are going to do today. So we are going to look at all this session one by one and try to learn it by using like few of the example, because it's going to be like more technical stuff like compared to like theory. Yeah. Okay, so before we move on, so let's try to do a very quick recap for the some of the rules that we actually learned previously in our first introduction lesson. Okay, so if you still remember, we talked about what is the definition of logarithm. So meaning if you have y equals to a to the power of x, meaning that you can always rewrite it in the inverse function, meaning in log. So like x equals to log base a and then y. Okay, so the base of your indices is the base for your log. Then after that, the power that you actually put at the base will be the answer for your logarithm. Okay, so some of the rules that we have learned before, like for example, multiplication rule, which you have log base a x y. When you expand it, then you can get log base a x, plus log base a y. Okay, then we have division law that we use log base a, then x over y, which gives us a minus. Okay, then we have the third one, which is the power law. When we have log base a x power m, then we can always rewrite the power in front of the log. Okay, and after that, the last one is the one that derived from the power law, which if we have an 1 over x, then we can always rewrite it in negative. Okay, so these are the few rules that we have learned previously. Then we will try to use it again today when we try to solve the equation. Okay, so the first thing that we are going to learn is how to solve logarithm equation. So when you look at all these questions, you can see that there's log equation, and I believe that in your IGCSE and in your SPM you learn this as well. Okay, so since log base ax only exists for x greater than 0 and a greater than 0 and a is not equals to 1, so you must make sure that when you solve the equation, right, it's good that you can put your roots back into the original equation to check that whether the roots fits the equation or not. So especially if you didn't actually carry out this step, then you tend to forget that your x and a must be something that is positive. Okay, so for this part, you are going to use the rule of equality of logarithm, which we say that log base a x will be equals to log a y, then your x will be equals to y. So meaning whenever, no matter what kind of equation that you are solving, you must reach to a step that you have only like two log with the same base. Okay, then after that only you can try to eliminate the log part and say that x and y is the same. Okay, so you must remember that is no the other term, meaning that it must be in single term without any plus or minus, and then in front of the log it must be nothing also. So it might be in a simple logarithm form. So for same base for the first part and the second part, then only you can say that the x is equals to y. Okay, so now we'll be looking at some of the example here together. So I just want to noted here again, like for those who learn this in SPM or in IGCSE. So in this syllabus, you are not required to learn the logarithm equation, which they have different base. So meaning that your syllabus doesn't cover the part for the change of base. So for all the equation that you are solving, basically they have the same base already. Okay, so now let's look at the three example together. Okay, so let's look at number one. So we'll start with an easy example first. Okay, so let's write down the law of equality that we have learned just now. Okay, so we have log base ax equals to log base ay. So when they are in the same base, then we can say that x is equals to y. So now when we look at this question, we can definitely see that they are both in the same base, which is log 8 already. So the thing that we might need to simplify is the 2 in front here. So how can we actually put the 2 at the other place so that we can have log ax equals to log ay? So by looking at this, then we can use the power law that we have learned previously. So how can we move the 2? So we can move it up to become the indices of x plus 2, correct? So by using the power law, log 8 x plus 2 square will be equals to log 8 2x plus 19. So when you look at this equation, so you can see that they are in the form of log ax and log ay already. So log A. So the whole thing here is your x and the whole thing here is your y. So when they are in this form, then we can always say that x plus 2 square will be equals to 2x plus 19. Okay, so now we can try to expand it. So x squared plus 2x plus 4 will be equals to 2x plus 19. So when we rearrange and solve it, then we'll get x squared. Sorry, this is 4. Okay, so we'll be able to get x squared plus 2x minus 15 equals to 0. Okay, so x plus 5 and x minus 3. So we'll be able to get x equals to negative 5 and x equals to 3. Okay, so you remember when you get the answer, you must check that whether your a and x is a positive or a negative number, correct? So this is for the checking part. The idea of checking is to check that your log ax, both of your a and x must be greater than 0. Okay, because when we look at this equation, it's very hard for us. I mean, you need to substitute to see whether this and this will there give a negative answer or not, right? Okay, so we can start to check with negative 5. So when x equals to negative 5, meaning that you will have log 8 2 log 8 and negative 5 plus 2, which this one will give you 2 log 8 and negative 3. So you can see you have a x here which is negative, so that's why this is undefined. Okay, so you can just write down like this one, so you have undefined. So that's why you know that you cannot accept the answer x equals to negative 5. So the same thing we need to check with the other one, x equals to 3 and see. So 2 log 8, 3 plus 2. So you get 2 log 8, 5. So which is correct. Then after that, the other one is log 8, 2x plus 19. Then you substitute your 3. So you can see that you are definitely going to get a positive number, right? So that's why they are defined. Okay, so this answer, then the solution here, sorry, I don't have enough space to write here, so I just write here. So the solution here will be equals to x equals to 3. Okay, so just to repeat, the purpose of you checking is to make sure that your a and x is a number that is not negative. Okay, all right, so let's move on to questions 2. Okay, questions B. So you can see compared to question 1, so this is harder to solve because instead of having the log term, you have the term that without log. So I'm going to show you two methods. How are you going to solve this? So I mean which they are equivalent. So depends on you like which approach that you want to take. Okay, so the first method that we are using is we try to use the idea of the definition of logarithm. So meaning that we know that y equals to ax, we can always rewrite them in a form of log base a y will be equals to x, right? Okay, so what we try to do for the equation, we try to group the log term together. So meaning that I will have 4 log x2 minus log x4 equals to 2. Okay, then after that, what I need to think is how do I combine these two log terms together? So log x, so I know that this will become 2 power 4, right? Okay, and then minus log x, maybe let us try to change this as well. So 2 to the power of 2 equals to 2. Okay, so now since this is minus, so you can always simplify them into division. So 2, 4 divide 2, 2. So equals to 2. So law of indices, if you have division, meaning that you should use your indices to minus each other. So that's why it will become 2 power 4 minus 2. So equals to 2. So you have log x 2 power 2, which gives you 4 equals to 2. All right, so now you rewrite the logarithm into indices. So the base of logarithm will become the base of your indices and your answer will become your power equals to 4. So when you solve it, you will be able to get x equals to positive or negative 2. Okay, so this is the first approach. So let's try to see what's the second approach look like. So the second approach, we are going to use the method that we learned just now, which if we have log ax equals to log ay, then we can always say that x will be equals to y. So by using this rule, then what we can try to do is we try to change 2 back into logarithm form. So meaning 4 log x2 equals to, so how can we change 2 into log form? So remember we learned an identity that log a x will be equals to x, right? So since the number that we want now is 2 and the base that we want now is x, so we can always rewrite the 2 in the form of log x squared. So when we try to simplify this, then we get exactly 2, right? Then after that, plus log x 4. Then after that, you continue to solve log x 2 power 4. So this is plus. So how can you combine them together? It will become multiplied, right? So log x squared multiplied with 4. So you will have log base 2 x power 4 equals to log x 4 x squared. So now you reach a time that you have log x and this is your x and this is your y. Okay, so 2 to the power of 4 give you 16, then it will be equals to 4x squared. So you can continue to solve it. X squared equals to 4 and x equals to positive and negative 2, which gives you exactly the same thing. So depends on you like which approach you want to take, but I say both are equivalent. Yeah, so depends on you are more comfortable with which one. Okay, so the same thing after you get the answer, you should do your checking as well. Okay, So we can see that this thing, your x is going to be the base, right? So we know that for the base, it cannot be a negative number. So that's why it's quite obvious that your x equals to -2 cannot be accepted. So that's why you can just say that since log, okay, only exists for positive base, then you can just write x equals to -2 is not the solution. Sorry. X equals to -2 is not the solution. Okay, then now you can continue to check the other one. So x equals to 2. So it's good that maybe you can straight away to substitute it and check. So like 4 log 2 equals to 2 plus log 2 and see whether it's correct or not. So 4, sorry. Okay, so you can see log 2 give you 1, right? So 1 equals to 2 plus 2. Is that correct? Yeah, so this is true. So after that, we can say that the solution is x equals to 2. All right, so that's the part for B. So now let's look at the C. Okay, so C, log base 3x squared minus 9 base 3x plus 14 equals to 0. So I purposely put in this question because I want to clarify to you the difference between these two terms. So for example, if I have log 3x squared and when I have log 3 x squared, do they means the same thing? So when you look at this one, you can see that the 2 here, the indices 2 here only belongs to x, but the 2 here belongs to the whole logarithm. So you must make sure that they are two different things. So for this one is the one that you can bring it forward and it become 2 log base 3x. So this means log 3x plus log 3x, which gives you like log 3. So log 3x plus log 3x give you 2 log 3x. Then after that, when you simplify, then you can always bring the 2 to become the indices of x. But this one, when you try to square it, what does that mean? It means that it's going to be log 3x multiplied with log 3x. So make sure that you are not confused with these two. They means exactly different thing. Okay. So when we look at this one, it actually refers to this term. So that's why you cannot bring your 2 in front of your log 3. So what we can try to do here is, if you remember back into P1 when we learned about quadratic equation, we learned something that is called substitution. So that's why this question we need to use substitution to do it. So I don't copy the question again. I mean, yeah, so you can try to copy it when you try to do the questions. So what we can try to do is we try to define a variable. So maybe let y equals to log 3x. So now we can try to change the whole thing here. So if y equals to log 3x, then we can always rewrite it in the form of y squared minus 9y plus 14 equals to 0. So now you can continue to solve it. So y minus 7, y minus 2 equals to 0. So I have y equals to 2 or 7. So now only we continue to solve it. So we have y equals to 2, so which means log 3x will be equals to 2, and the other one is log 3x will be equals to 7. So we need to continue to solve this. So log 3x equals to 2. So meaning that we can always rewrite it. So depends on you lah. So I would say if you want to change 2 into log 3x also can. If you want to rewrite them into indices form also can. So depends on you. So I might just do indices here because it's easier in this case. So you will get 3 squared equals to x, right? So x will give you 9. Then after that, the other one, you have log 3x equals to 7. So 3 to the power of 7 equals to x. So you have x equals to 2187. Okay, so this is what you have. So same thing, now you might need to check. Okay, so for the checking part, then you can substitute them straight back into the equation. So x equals to 9. So by looking at it, I guess that these two solutions can be accepted. But yeah, let's check. So you have log 39 square minus 9 log 39 plus 14 equals to 0. So here you will get 2 square minus 9 1 plus 14 equals to 0. So is it correct? Oh, sorry, this is 2. Okay, so 4 minus 18 plus 14, which gives you 0. Yeah, so which this is true. So after that, you check the other one, x equals to 2187. So log 3 2187 square minus 9 log 3 2187 plus 14 equals to 0. So 3 to the power of 7. So 7 2 minus 9 7 plus 14 equals to 0. So you can check 49 minus 9 63. Yeah, so this is true also. Okay, so that's why the solution here is x equals to 9 or x equals to 2187. So both can be accepted. Okay, all right, so now let's try to look at the next section. Okay, so we are going to see how do we use the logarithm concept to help us to solve exponential equation. So exponential equation is basically the equation with exponential functions inside. So in your IGCSE, you already know how to solve exponential equation, like the easy one, like 2 square will be equals to 4x. So you know that what you need to do is you only change the base of your exponential become the same. Then after that, you say that 2 is equals to 2x. Then after that, x equals to 1, something like that. Okay, but for today's session, we are going to look at the equation which you actually cannot convert it into the same base. So meaning that when you look at the question, you see 2 and 3 and 4, they don't have the same base to change. Same thing like 5, 3 and 7, they also do not have the same base to change. So we are going to look at those questions today. Okay, so let's try to see number 2A. Okay, so from the questions, then we have 3, 2x equals to 4x plus 5. Okay, so when you have something that you actually cannot change them into the same base, then what we will try to do, we will try to take log to both sides. So meaning that what are we trying to do here is we try to add in logarithm into this equation. And normally the log that we are going to take is going to be log 10. Okay, because that's the log that we can solve with our calculator, and that's like a special kind of log. Okay, so what we try to do here is putting the log in front of both sides. So try to log both sides. Alright, I'm used to use the word algae because I do not like to confuse with like log and whether am I forgot to write the base or what. So that's why instead of like using log, I prefer to use algae. So but depends on you. You use algae also can. So like what I have explained previously. So if you want to say like log 10, so it's the same thing when you say log without putting a base or if you put algae. Yeah. But normally I will say when you look at your textbook, they normally use log lah. So depends on you which one you want to take. Yeah. So but normally I take algae because of I do not want to have the case that where I write log, but it's actually I forgot the base. Yeah. So I want to differentiate about like a normal log with a base or without a base with like the log 10. Okay, so algae 4, then x plus 5. So when we want to continue to solve this, then we can use the power law that we have learned previously. So try to bring the power in front. Okay, so x plus 5, then I have log 4. Alright, so the next thing that you need to do is try to group them together, or you can try to expand it. So 2x log 3. Then for this part, you will have x log 4 plus 5 log 4. Okay, so now you can try to group the log that have the same coefficient together. So 2x and x here, right? So that's why I'll try to do factorization. So okay, let me just try to write them together first. So that's why it's easier for you to see it later. So 5 log 4. So since I have x for this both terms, so that's why I can bring it up. So 2 log 3 minus log 4 equals to 5 log 4. So now I want to get my x, right? So I bring the whole thing to become the denominator here. So 5 log 4 divide by 2 log 3 minus log 4. Okay, so you can use your calculator now. So you just press in whatever that you have. So 5, remember your bracket, okay? 5 log, so log in your calculator is basically in log 10 already, in base 10. So 4, okay, then after that, 2 log 3, remember to close it, then after that minus log 4. Okay, so you should be you should able to get the answer for 8.55 because the question one in three significant figure, right? So 8.55 in three significant figure. Okay, so that's it. Easy, right? Yeah, so now let's try to look at B. Okay, so B. So this is a very easy question also. I'm just putting it in because I think it's like kind of interesting because when you first look at this question, you might find like very confused. How can you actually continue like you have three different terms here? So but then the idea is actually very easy. So what do you need to do is you just group the term that with the same identity like together. So instead of like writing 5 3x equals to 7, you can always change it into 3x equals to 7 over 5. Then after that, everything will be easy already. So because of these two terms, you cannot have the same base, right? For you to solve x. So that's why same thing, we try to take logs to base 10 for both sides. So log 3x will be equals to log 7 over 5. Okay, so you can continue to do the thing that you always do. So bring the x forward. Then after that, x will be equals to log 7 over 5 divide by log 3. Okay, so please make sure that this thing is not equals to this thing, okay? So this only correct if both of this term is under the same log. So this and this, they doesn't mean the same thing. So please make sure that when you press your calculator, it must be in correct form. Okay, so now let's try to use the calculator again. So log 7 over 5 over the whole thing, log 3. Okay, so you will be getting your answer 0.306. Same thing, three significant figure. Okay, so there's something good about this kind of question which you can just use your calculator. This is not necessary in the working, but it's just that you can actually use your calculator to check everything. So when you get this answer right, when you put it back, then you can get 0.0306 equals to 7. So you can use your calculator to check whether you can get the answer or not. So since you have this as your answer already, right, then you don't erase it off. So you just 5 to the power of the answer that you get. Sorry, it should be 3. 3 to the power of the answer that you get. Then after that, you multiply by 5 and see whether you get the answer. So 7. So which means your answer is correct. So for exponential equation, normally you can just use your calculator to check whether your answer is correct or not. Alright, so let's move on to C. Okay, so now let's look at question C. So when you look at this question, you can realize that this question is a bit different with the BC that we did just now, which we can obviously see that is exponential functions that you actually cannot change the base to the same base. So that's why you are using log to solve it. So you know, in equality of indices, we talk about when we can have ax equals to bx, then we say that x equals to b. Or the other one is when you have ax equals to ay, so you can say that x equals to y. So the issue about this question is that you have a plus here, which you cannot easily change it into a single term, which like ax equals to bx. So you cannot combine these terms, so that's why you cannot have like 4 something equals to 4 something, then you cannot say that the indices are the same. So that's the problem with this question. So how are we going to do this? So I will show you 2 methods as well. So depends on you which one you want to take, but yeah, both is fine for me. Okay, so the first one is what you can try to do is just by using the substitution that we did just now. So what you can try to do, just let y equals to 4 to x. Okay, then you try to change your equation. So 4 2x plus 4 2x minus 1 gives you 4, correct? So but remember that for here, you must change it first. If not, then later you are going to confuse yourself. So 4 2x plus, so how are you going to write this in a better way? So 4 2x, you will need to multiply with 4 negative 1. Correct? So this is how you get to here, right? So when you multiply, then you need to plus the indices together equals to 4. So 4 2x, now you can try to substitute already. So 4 2x is y. So y plus, so 4 power of negative 1 is 1 over 4. So that's why you have y over 4 equals to 4. So you get 5 over 4y equals to 4. So when you solve it, then you can get y will be equals to 16 over 5. Okay, so after you get this, then you can continue to solve it. So 4 2x will be equals to 16 over 5. So this is the step that you can see that you cannot change them into the same base. So that's why we need to use log. Sorry, I'm writing here because I scared later I do not have enough space there. So that's why, so putting both log to the both side. So same thing, 2x log 4 equals to log 16 over 5. Okay, so you can continue that you have 2x equals to log 16 over 5 divided by log 4. Okay, so same thing in your calculator. So log 16 over 5, oops, the whole thing here, then over log 4. So you can get, oops, you see, so you must remember to write, what is that called? You must remember to put your bracket, okay? So log 16 over 5, whole thing bracket, then divide by log 4 bracket. Okay, so you will get 0.839. So you, since you need to get x, right? So straight away divide by 2. So 0.420. So or you can write in 3, that will be more accurate. So 0.4195 also can. Alright, so after you have get this, then this will be your answer lah. Okay, so now I'll be showing you method 2. So for method 2, they didn't use any variable to replace it, but then they try to use the method of factorization, but they actually means the same thing. So for 2x plus 4 2x minus 1 equals to 4. Okay, so instead of doing substitution, what we try to do is we do something like factorization. So what do you have? Like 4 2x and 4 2x minus 1 equals to 4, right? So we can bring 4 2x out. So how do we get the original thing? So 4 2x, how do you get 4 2x here? 1. So you only multiply by 1, then you can get 4 2x, right? So what do you need to multiply from 4 2x for you to get 4 2x minus 1? You need to multiply by 4 negative 1, correct? So when you multiply, then when you add them up, then you can get the original thing, which is 4 2x minus 1 equals to 4. So 4 2x, so you can solve this part. So 1 plus 1 over 4, you get 5 over 4 equals to 4. Then after that, 4 2x, same thing. You bring this over here, then you are getting 16 over 5. So you see you are getting the exactly same as this already. Then you can continue the same thing like what you have done previously. Okay, so depends on you which method you want to take, but they basically, when you look at this, it's like the same thing, but then they didn't put another variable for the 4 2x, but what they try to do is they just bring it outside, then after that like do it somehow like your factorization lah. But one thing about this one is you must make sure that you are very confident with the part that what is the thing that you need to multiply. So if you are not sure, then maybe in here, then you can try to add one step like 4 2x plus 4 2x times 4 negative 1 equals to 4. So after you do this, then it will be easier for you, which you can see 4 2x 4 2x. So you bring out 4 2x, then what do you left? You left with 1 and 4 negative 1. Let's look at the last question. Okay, so this is the last question for this part. Okay, so when you see this question, so the thing that you need to solve is for the 3x and 3x thing. But then so we can't use factorize in this form because it cannot be separated into two. So when we try to split it up, then what you can see is the most that what we can try to do is it will become like 3x squared, correct? So when you multiply, then this is how you get 2x, and then plus 7 3x equals to 15. So when you see something like this, then this is similar with the question 1c that we did just now. So what we need to do is you just let y equals to 3x. Okay, then you can substitute 2y squared equals plus 7y equals to 15. So as you continue to do this, so try to arrange them into a quadratic equation. So minus 15 equals to 0. So factorization, 2y minus 3 and then y plus 5. So you would be able to get y equals to negative 5, and the other one is 3 over 2. So after you get this, then now you can try to put it back. So you have your y is negative 5, so meaning that 3x equals to negative 5. So how can you solve this? So they are not in the form of the same, you cannot change them into same base, right? So take log to both sides. Okay, so what can you realize? You cannot solve for log negative 5, right? So that's why this is no solution. So no solution for log negative 5. Okay, so same thing. Now you can check 3x equals to, it's not check lah, it's like now you want to solve the other one. Okay, so same thing, putting log for both sides. Okay, so x then become divide. Okay, so try to use your calculator, then you should be able to get 0 point in 3 significant figure. So you will be able to get 0.39369 and so on. So three significant figure. Okay, so you will have your answer x equals to 0.369. Alright, so that's the question. Alright, so let's look at the very last section now. Alright, so this will be our last part for the lesson, which is how to solve exponential inequalities. So it's going to be a quite short one because it's similar to what we have done just now for the exponential equation. But now instead of like the equal to, then we are going to do greater than or smaller than. Okay, so since we are only solving exponential inequalities by using the logarithm, so the thing that you need to know is that the symbol will not be changed when you try to put log at both sides. This is applies for base 10 only, all right? So meaning that if we are solving an inequality in exponential inequality that we cannot actually change them into same base, then when we try to put log at the both side, the symbol of the inequality will not be changed. So however, please remember that when you try to divide or multiply something with a negative number, then your inequality symbol need to be reversed. Okay, so we'll be looking like two examples here together so you can understand the concept better. Okay, so number 3, solve the inequality, give your answer in terms of base 10 logarithm. Okay, so same thing. So what do you need to do is do it like how you solve a logarithm equation is the same. So I mean obviously you can't change them into the same base. So let's try to take log for both sides. Okay, so the x, bring it forward. Okay, so when you want to solve for x, meaning that you are going to divide by 0.6, right? So this is the step that you need to be very careful. So when we talk about algae or we talk about log, we talk about log 10. So you know that log 10 give you 1, right? And you know that log 1 gives you 0. So normally anything that is lesser than 1, they will give you a negative answer. So meaning like log 10, let's say 0.1. So 10 to the power of what gives you 0.1? Negative 1, correct? So you can see that this one will give you a negative answer already. So I guess anything lesser than 1 will give you a negative number. But then every time when you want to do this, you use your calculator to check. Like for example, when you want to divide by log 0.6, then you see log 0.6. Okay, so although this term is like in a positive, but when you actually press it in the calculator and when you look at the value, it's a negative value. So you must make sure that when you have something like this, so because you divide by a negative number for both sides, right? So that's why you will need to change your sign. Okay, then after that, then only you continue. So the answer want to leave the answer in terms of log base 10 logarithm. So this will be your answer lah. If the answer want in terms of three significant figure, then you just use your calculator to solve this and to get your answer. Okay, so that's it for the A part. So let's try to look at the last questions. Okay, so let's look at the last questions. So it's quite easy also. So when you look at this question, then this is similar to the example 1B. Oh, sorry, 2B, I think, that we did previously. So the same thing, you can move over the 4. Okay, so take log base 10 of both sides. Move the indices forward. So make sure that you put them into a bracket, okay? All right, so expand it. Okay, you might have a question here is can you don't expand it, so straight away bring the log here, then plus 1 divided by 2. Yes, you can. So if this question were to ask you to just put your answer in three significant figure, you can always do that. You are going to get the same answer. Yeah. So okay, I'll just show you like both lah. So 2x, so this is when I expand it. Okay, So I want x only, so I'll do everything in one shot. So log 5 over 4 plus log 3, then divide by 2 log 3. Okay, so to simplify this, then we'll try to write the 2 at the top of 3. So log 5 over 4 plus log 3 divide by log 3 2. Okay, so this is your final answer, giving your answer in terms of base 10 logarithm. Okay, so if the question want you to write your answer in three significant figure, then you just solve this part lah. Okay, so if you don't want to expand it, then how is that look like? It's actually the same thing also. So 2x minus 1. So you're going to have log 5 over 4. Then you divide by log 3, right? Then after that, when you want 2x, then it will become x. Then after that, log 5 over 4 divided by log 3 plus 5, and then the whole thing divided by 2. Okay? It's totally fine if the question want your answer in three significant figure, because when you press in calculator, you can try it out. You should get the exactly same answer when you press this thing or when you press this thing. So you are going to get the exactly same thing. But then if the question want you to write in terms of base 10, then you realize that it's very hard for you to simplify this one instead of this one. Yeah, so that's why. Okay, so and something that I forgot here, so make sure that when you try to bring the log 3 here, check your calculator. So in your calculator, your log 3 should give you a positive answer. So that's why I do not need to change the sign here. Yeah. So this is a bad demonstration which I didn't check first. Yeah, because I know already like 3 is greater than 1. So it's definitely going to give me a positive answer. But it's good that you try to check it out. Okay. Alright, so after you get the answer, then you can try to substitute inside the calculator and see whether you get the answer or not. So it's the same like, okay, maybe let me just try to check the answer out for this question. So 5 over 4, so I try to press this, plus log 3, and then divide by log 3 power 2. Okay, so I'll be able to get 0 0.6016. Okay, so it will be x greater than. So same thing, maybe let me try to press this and see whether I get the same thing or not. So I have log 5 over 4 divided by log 3, and then plus 1 divided by 2. Okay, so you can see I get the exactly same answer. So since we know that this is our answer, so x should be greater than 0.6016 for us to get an answer greater than 5. So maybe let us just put like x equals to 1 and see what happened. Okay, so because any number that greater than 0.6 will do, right? So you can put any number in. So I will just check 4 times 3 to the power of 1. So 2 times 1 minus 1 is 1. So you are going to get 12. So 12 is greater than 5, which means it's correct. So or if you want, then you can try to check with like 0.7. So 4 times 3 to the power of 2 times 0.7. Then after that, minus 1. Okay, so you see you get an answer that's greater than 5 as well. Or you can just try to put in a number that is smaller than. So when you put 0.5, you see you get a number lesser than 5. So which this answer is like a correct one. Alright, so that's it for this part. So try to complete your exercise and so on. If you have any question, then you can ask me personally. Alright, thank you.